Good day everybody, I'm Anish Rishi. Today I'll be presenting on the topic application of automata theory in game theory. I chose this topic because ever since I was a child I was fascinated by the world of games and how they functioned. Now that I can actually understand their working behind the scenes, I decided to make a presentation on this topic. Today's agenda is types of automata, application in game theory, and finally the conclusion. Automata theory is a branch of computer science that deals with the study of abstract machines and automata and their computational capabilities. Game theory, on the other hand, is a branch of mathematics that deals with the study of strategic decision making. Any problem with interactive participants and actions can be treated as a game. Game theory studies rational behaviors, and therefore, game theory will only work when people play games rationally, and it will not work on games with cooperational behavior. Game components. A game consists of the following entities: players, the people playing the game, where one side of the game tries to maximize their gain while the other side tries to minimize the opponent's score. The environment. This includes both positions and the possible moves for the players. And the successor function includes actions and returns a list of pairs, where each pair indicates a legal move and the resulting state. The terminal test specifies when the game is over and the terminal state is reached. Utility function is the numeric value for the terminal states. Models used in games are applicable to be used in real life situations. Because of this, game theory has been broadly used in economics, biology, politics, and also in computer science. Now, what is the basic definition of automata? Automata are mathematical models that are used to study the behavior of systems. It is a self-operating machine in which output to one automata is a combination between the consequences of the current input and the history of the machine's previous input. The automation consists of states and transition. The state is represented by circles and the transitions are represented by arrows. Automata is the kind of machine which takes some strings as input, and this input goes through a finite number of states and may enter the final state. The one which doesn't enter the final state is also considered as a rejected state, and it's not considered for the future purposes. We shall now discuss about the types of automata. There are several types of automata, including finite automata, adaptive automata, and cellular automata. Finite state machine is a mathematical model of computation. It consists of a finite number of states and transitions between those states. It is used to recognize pattern within input sequences. Moving on to the pushdown machine. A pushdown machine is a type of automation that can recognize context-free languages. It has a stack that can be used to store information about the input stream. Turing machine. The Turing machine is a mathematical model of computation that can simulate any computer algorithm. It consists of an infinite tape divided into cells, a read-write head that can read and write symbols on the tape, and a finite set of states. It is used to recognize recursively enumerable languages. Cellular automata are discrete models of computation studied in automata theory. They consist of a regular grid of cells, each in one of a finite number of states, such as on or off. They evolve over time according to a set of rules based on the states of neighboring cells. Adaptive automata or cellular automata that change their rules based on their environment or input. Now, moving on to application of automata in game theory. Automata theory has several applications in game theory. In game theory, automata are used to model the behavior of players in a game. Players are assumed to be rational and they choose their strategies based on the strategies chosen by the other players. Automata are used to model the strategies chosen by the players and to predict the outcomes of the game. There are several strategies that are used in game theory, including the Nash equilibrium, the min-max strategy, and the maxing strategy. In the next slide, we will be discussing on the TFT strategy. One of the most popular strategies is the tit for tat strategy, which is a simple but effective strategy that is used in many real world situations. It is a strategy used in game theory for the iterated prisoner's dilemma game. In this strategy, a player cooperates on the first move and then copies the opponent's previous move on each subsequent move. This means that if the opponent cooperates, the player will cooperate as well. If the opponent defects, the player will also defect. The TFT strategy is known for its simplicity and effectiveness in many different scenarios. Finite state automata are widely used in game theory. In fact, finite state machines have been employed in game designing. The states and transitions can be utilized to represent different actions, rewards in the game's environment. The role of the finite state machine in game theory is that the complex behaviors can be characterized and then they can be encapsulated into many single interactions which are called as states using finite state machines. In finite state machines, each state can be expressed as direct actions. As you can see in the diagram, it has four states C1, C2, B1, and D2. The arcs between the states represent the transitions. Finite automata are found effective in representing simple strategies in game theory. Adaptive automata are a type of automata that can change their behavior based on their environment. They are often used to model systems that are subjected to change, such as the stock market or the weather. In game theory, adaptive automata are used to model the behavior of players in a game when the rules of the game changes. The advantages of using adaptive automata are that any automation can be turned into an adaptive automation by allowing its rules to change dynamically. The process in which it can be done is that the action type can be either a query, either a remove or insert actions, which can be represented by the question mark, the minus symbol, and the plus symbol. The figure illustrates the concept of adaptive automata, where the discrete arrow between D1 and C2 is created when the transition between C1 and C2 is accomplished. The accepting procedure performed by an adaptive automation is done efficiently due to their structure, which is based on finite state or structured push-down automata. Adaptive automata can handle context dependencies in a strict syntactical way without the aid of auxiliary semantic procedures. Generally, adaptive automata have cheaper implementation compared to other mechanisms, which can be considered as an alternative to existing solutions of natural language processing. Cellular automata are a type of automata that are used to model systems that have a large number of interacting components. They are often used to model complex systems, such as the behavior of crowd or the spread of a disease. In game theory, cellular automata are used to model the behavior of players in a game when the players are a part of a larger system. The structure of cellular automata is based on the lattice of cells, where each cell may be in a predetermined number of discrete states. Updating the state of each cell is carried out using a transition rule. In cellular automata, the cells are regularly arranged in n-dimensional grids. Each cell has an initial state selected from a finite set of states. Update is carried out in a discrete timestamp. Changing the state of the cells depends on the set of local rules. The selected transition rule is applied to all cells. The update process is then carried out simultaneously for all cells. Cellular automata come in different shapes and varieties. The simplest cellular automata is one-dimensional, with cells on a straight line, where each cell can have only two possible states, such as high, low, or black or white. However, other shapes are also possible. In a two-dimensional space, common cell shapes are squares, hexagons, and cubes. In theory, a cellular automata can have any number of dimensions, and each cell can have any number of possible states. The state of each cell changes in discrete steps at regular time intervals. At any given time, this state depends on the following rules. Its own state is the previous time step, and the states of its immediate neighbors in the previous time step. In conclusion, automata theory plays an important role in game theory. In game theory, presenting players with strategies directly affect the performance of the players. Utilizing the power of automata is one way of presenting players with strategies. Different types of automata, such as finite automata, adaptive automata, and the cellular automata, have been discussed. We have also discussed and analyzed the characteristics and the underlying structure of the existing types of automata. Consequently, we have explored the applications of automata in the game theory. Thank you.